Welcome. We're going to talk about radicals, not the 80s slang term, although we could talk about that too. Pop quiz. What were Bill and Ted's, what was the name of their band? And where were they from? All right, let's get started on radicals. What is a radical? Well, actually, this symbol right here, there's my little arrow, that's a radical. The number underneath the radical is called the radicand, and there is something missing from here. There usually, or sometimes, will be a number located right here. That's called the index. When there is nothing written, there's nothing there, it's actually a 2. And that's where we get our square root. Might be asking, why are we talking about radicals? Because they're another way of writing exponents, rational exponents, especially when we have fractions or fractional exponents, right? So here's our base. A is any number, non-zero, any integer, let's say. And we have our exponent here, which is rational. It's m over n, where n does not equal 0. I can write this using radical notation. Just means we're going to use radical symbols. Where my index is n. I don't like that. I'm just going to use my pointer here. My index is n, which is the denominator. And then my numerator for my rational exponent sticks with the base. And so now it's a raised to the m power. And this is another way of writing that. My index stays the same. It's the nth root of a, and then I raise that entire thing to the m power. So some sample problems here. Let's just see the last slide in action. So I have 7 raised to the half power. I'm going to write that using square root notation. Radical notation, and I'm going to write a square root. And it's just the square root of 7. When we don't have a number there for the index, it's understood that it's 2. Just like when I have, let's look up here, when I have the number 3 and there's no exponent, it's understood that it's 3 to the first power. Here, a square root means there's nothing there, and it's understood that it's 2. This is asking what number times itself equals 7, right? And we're going to times itself to itself twice. So there is no whole number that works. So we'll move on. Here we have something in radical notation, and we're going to write it using exponential notation, meaning we're going to write an exponent. So here's my index, and here's my base. The radicand is the same as my base, and my index, this is to the first power, so I have a 1 in the numerator and a 3 in the denominator. We're going to do it again, a little more complicated now. We have a number in the numerator and then 1 in the denominator. I'm changing to a hand here. Maybe that's helpful. I don't like it. Let's stick with the arrows. Okay, so I'm going to write this in radical notation. This is my base, so I write 7. I'm going to be using the radical symbol here. And I have a 3 in the denominator, so this becomes my index, and 4 in the numerator, and I can write the 4 here, or I can write it like this, parentheses around my cube, or the third root of 7, and then I raise that number to the 4th power. Okay, over on this one, we're starting in radical notation. We're going to change it to exponential notation. So the radicand is the same as my base. The 4 is my index, so that's in the denominator. And the 5 is my exponent, and so that goes in the numerator here. And I have 5 raised to the 5/4 power. So even we did this, we talked about this before with rational exponents. We can simplify these, okay? So this is kind of review. We've done this before. This is a power to a power, so when I have an exponent here on the outside of parentheses and an exponent here, I'm actually going to multiply 1/2 times 6 in my exponent. So I have x is my base raised to the 6 times 1 over 2. And I like to write my 6 over 1. So that helps me remember when I multiply fractions, I do it straight across. 6 times 1 divided by 1 times 2. So let's rewrite that. 6 times 1 over 1 times 2. And then I'll simplify that as 6 over 2. Simplify one more time, x cubed. Okay, do this one a little faster. This is 81 times m to the 6, and then in parentheses raised to the 1/2. So I am going to say this is 81 to the 1/2 times m to the 6 times 1/2. So this should look familiar. This is 81 to the 1/2 and m cubed. What's 81 to the 1/2? Let's switch this over to radical notation, and it's the square root of 81. I have a button for this on my calculator. Times m cubed. This is outside of the radical. The square root of 81, what's a number times itself equals 81? Well, that's 9. So this is my final answer. This is kind of bonus material. If you know how to do this, you can go ahead and skip ahead. If you're one of my students, you need to focus. So how do we simplify, or another word for this is evaluate, sometimes we'll say solve, square root problems? Okay, this will be a skill you'll use later on if you go on to higher maths. What's the square root of 144? Square root of 144? Sorry, read that. What number times itself is 144? Well, that's 12. Oops, sorry. That's 12. That's what we call a perfect square. Perfect square, this number is a perfect square, meaning when I take the square root of this number, I get a whole number. And technically, the answer is plus or minus 12. For now, we're going to focus on the positive, okay? But there are two answers to each of these problems. What's the square root of 12? Well, I'm going to get a decimal, so I want to simplify. I can break this apart. I'm going to factor 12 into 4 times 3. Well, that's the same as the square root of 4 times the square root of 3, okay? 4 is a perfect square. The square root of 4 is 2 times the square root of 3 is my final answer. 3 is not a perfect square. I cannot simplify it anymore, so I'm done. This is what simplifying means. It means I'm going to pull out from here any perfect squares that I can, and I'm going to take the square root of those perfect squares, and that answer goes in front of the radical symbol. Square root of 72. Well, I'm going to rewrite this as a factor of 36 times 2. And that, which is the same as the square root of 36 times the square root of 2. And the square root of 36 is another perfect square. What's a number times itself that equals 36? Well, that's 6. So 6 times the square root of 2 is the simplified version of the square root of 72. So 2 times the square root of 6, 2 is already simplified. I don't need to simplify that anymore. Times the square root of 36, so I'm going to use parentheses here. What's the square root of 36? Well, if we remember what we did here, we know that number is 6, so that's just 2 times 6, and that equals 12. Radical notation, as our recap. That's when we're using the radical symbol. Sometimes it'll be just a square root. Sometimes it'll be a cube root. Could be a 5th root or an 11th root. Okay, doesn't matter how complicated. We can always rewrite it as an exponential expression and so forth. So if I was going to write these in order, exponential notation of our first one here would be 7 to the 1/2, and then I'm going to go down. The cube root would be 7 to the 1/3. The 5th root would be 7 to the 1/5, and the 11th root would be 7 to the 1/11th power. Okay, so this over here is our radical notation. We're using the radical symbol. We have a radicand in our index. Over here, we're using exponential notation. We have our base, which is the same number as the radicand, the number underneath the radical symbol. And we have our exponents. In this case, they're rational, they're fractions, and that's okay. Simplifying square roots, we're going to look for perfect squares to factor out from underneath the radical. Okay. We might work on this another time, but it would be important, it would be helpful and just quicker to do some of these processes if you memorized some of the first perfect squares, at least the ones between 1 and 100, 64, 81, and 100. There are 10. The square root of each of these is just 1 through 10. These are the first 10 perfect squares. Your assignment, if you're in my class, is to do the worksheet for radicals and rational exponents. Hope this has been helpful. If you have any questions, you know how to get a hold of me. Good luck.